Okay, kids, here's the video for the lesson for Wednesday, April 1st. So this video exists for, if we are going to do a live Zoom lesson at 12:50, going over this worksheet. But this video exists, so if you want to preview it, you can go through this, or if, the 12:50 time doesn't work for you and you need a lesson to look at, this will hopefully help you out. Okay, but I will be going over this in detail and be able to take questions at 12:50 on Wednesday through the Zoom link. So some of this is going to be review, some of this is going to be new. Remember, we're going to use our perfect squares. Our perfect squares: 4, 9, 16, 25, 36, and so on. This list goes for a long time, goes forever. To simplify, we want to find perfectly, ideally the largest perfect square that divides into the number here. But any perfect square will do. So the biggest perfect square that goes into 45 is 9. Goes in 5 times. So I'm breaking it up. I always write the perfect square first. Remember, the square root of 9 is plain old 3. That comes out. And the 5 is left inside. You can't do anything more with this 5 because there are no perfect squares that divide into 5. So we're actually done with it. On problem 2, we can't simplify either one of these because there's no perfect squares that go into 6 or 3. But because these are both roots, we can multiply them. So root 6 times root 3 is root 18. Now that does have a perfect square that goes into it. Again, it's 9. We can break this up to 9 times 2. Square root of 9 comes out as plain old 3. What's left inside? Root 2. Now my pen just stopped working. Hopefully it'll come back here in a moment. Bear with me. There we go. I don't know why it does that sometimes. It's a new battery too. All right, here, 16 actually is a perfect square, so that comes out as 4. Now, if you remember from before break, any kind of even power, that comes out of the root and you just cut the power in half. So it's actually just a one-step problem. We're done right there. 4x to the third, because x to the third times x to the third is x to the sixth. Now I'm going to add another problem right here. We'll call this 3a, and we'll do one with an odd power. Okay, so I'm going to do, square root of 12x to the 10th power. All right, so the 12 is not a perfect square. Actually, I said I wanted to make this, I'm going to change that to the 11th power because I want an odd power. The 12 is not a perfect square. We're going to break that up to 4, because 4 is a perfect square, times 3. Whenever you have an odd power, you just reduce the power by 1. So you write x to the 10th times x. Remember, there's an invisible 1 here. And when you're multiplying, you add these exponents. So 10 plus 1 would be 11. So we can break x to the 11th up to x to the 10th times x. Now we can finish this up. This comes out as plain old 2. Remember, any even power comes out, you just cut the power in half. So what's left inside? This 3 and this x. And we're done. Okay. Square root of 300. That one's easy, right? Break it up to 100 times 3. That comes out as 10. What's left inside? Root 3. Okay. Now here again, similar to the problems we did earlier, we can multiply those. That's going to be square root of 75. That breaks up to 25 times 3. This is going to be 5 root 3. Okay. This one here, 24 times 2 times 3 is actually 144. Now remember, there's an invisible power of 1 and a power of 1. We add those, we get x squared. That's good because it's an even power. Square root of 144 comes out as 12. Square root of x squared is just x. Okay, page 2. So this is going to go back, this is like combining like terms, okay? If we have something like this, 5x plus 6y minus 7x plus 11y, what can you combine? You combine the like terms. Sorry, this 5 disappeared. 5x minus 7x would be negative 2x, and 6y and 11y would be 17y, and we would be done. This is the same, okay? We combine like terms. A root 11 can be combined with when we're talking about combining, we're talking about adding or subtracting. Root 11s and root 11s can be combined. So 9 root 11 minus 4 root 11 is just 5 root 11. 4 minus 5 is negative 1. Negative 1 plus 11 is 10. Notice how the root's not changing. Okay, it's like if I have 9 apples and I take 4 apples away, I have 5 apples. It's still apples. Okay, same thing down here. 3 minus 5 is negative 2. Negative 2 plus 10 is 8. Let's check that answer down below. Looks good. Okay. Now, here, this one, at first glance, it looks like they can't be simplified. Well, or can't be combined, I should say. Simplify this first. You can break this up to 9 times 3, which becomes 3 root 3. Now I bring that down. I do have like terms. I have root 3's. Together I get 8 root 3. Okay. Let's do one that's a little bit different. We'll call it 10a. How about if I have root, I don't know. Actually, we'll call it 5 root 3 plus 2 root 12 minus, I'm just making this up here as I go, root 18. So again, at first glance, it looks like you can't combine anything, but let's see what happens. Let's bring the 5 root 3 down. Can't do anything with that. Let's simplify this. Root 12 can be broken up to 4 times 3. This 4 comes out as a plain old 2, turns that into a 4. Okay. This can be, let me get my pen back. This can be broken up to 9 times 2. That comes out as plain old 3, so that's minus 3 root 2. Here we have like terms. 5 and 4 is 9. This we can't combine with that. We're actually done. Okay. One more. Again, it looks like this can't be combined, but let's simplify. That can be broken up to 100 times 2. The 8 can be broken up to 4 times 2. This comes out as plain old 10. This comes out as plain old 2, and now we can combine them to 12 root 2. I did go a little bit quick there at the end. But remember, there's going to be a live lesson about this unit at 12:50 on Wednesday. So make sure you're ready to go, have a blank sheet, maybe print it out, and you'll be able to ask questions as we do it. Ready to go at 12:50 with the Zoom link from the Canvas page. Okay?